Okay, well, good morning to you guys. I hope you guys are doing well. I hope you guys had a nice, restful weekend. We are working on a few things here. So, working on the normal distribution. Okay. Well, let's see. Hopefully, you guys are nice and online. Now, let's go back to think about some things here. Let's go to the browser. And I'm going to show you guys here. This is 227. Just to remind you, we are putting all our lectures here. This is part 1, the introduction. This is going to be part 2. I put examples here online for you guys. And the lecture notes, it's there. And let's go to the schedule. And so in your schedule here again, notice test 3 is going to be, today is April 27th. So we're down over here. Test 3 is going to be a week from today. So a week from today, you're going to have your test number 3. So I hope you guys are all good to go with things like, you guys can all upload appropriately. You learn how to do that by using some scanning software for your phone, taking PDF files, uploading that in Canvas in the announcement portion, because we're going to be doing that soon, next week again. So I just want to let you guys know we're headed there again. And let's go back and continue where we left off. Where we left off was working with that normal distribution, right? Remember this here? These notes here. It's coming up. The normal probability distribution. And, we went through some of these last time. It wasn't perfect. It's heartbreaking. I think we went through the areas of the curve, right? What percent of the ballot is shaded? We went through that lecture. What percent of the ballot is shaded? What about symmetry? We talked about those things. And then, let's go through this here. Let's find this here where we're at. What percent of the ballot is shaded? Yeah, we talked about all these things as an introduction. Right tails, left tails. Ooh, we did a lot. So anyway, okay, what percent of the ballot is shaded? Yeah, we went through this as well. Look at all the work we did. All right. So let's find where we're at. And here we are now where we started to talk about what's called the normal or the standard normal probability distribution. We even talked about that. It's a normal distribution, if you guys remember, where the mean is 0 and the standard deviation is 1. So the mean is 0, standard deviation being 1. So I'm going to go here and look at some of my notes and find what we need. Isn't there? No, let's find what we need here. All right, normal, standard, normal table, yeah. All righty. Okay. So I'm going to bring some of this in for us so I know where to go. Okay. So here's essentially where we're at, ladies and gentlemen. Okay. We're here. Now, in order to do a real question about, the normal probability distribution, in order to really be functional with this, we have to do the following here. Remember what I said. And, okay, let's go to the iPad, I guess. Let's try this out. So I have to go all the way down to the pages here as well, because we're going to talk about the standard normal distribution. And I'm going to introduce you to what's called a table here, a Z table, and that's where we're at, right here. Okay, the standard normal distribution. So I have online, just to kind of talk about this. This is a normal distribution. It's called the standard normal. The mean is 0. Standard deviation is 1. So if you see here, you go, oh, the mean is 0. Yes. And then you say, but Mr. Judge, I see a Z value here, and you're right. So whenever you're referencing the standard normal, where are we? Okay, standard normal here. Oops. Yes, it's represented by the letter Z. And this is what we said. Mu is 0, sigma is 1, and we're going to think of this as a Z value now. So we want to know, again, what percent of the bell is shaded here, okay? So if you look at this picture here now, if I said to you, what percent of the bell is shaded, we can start to answer some of the same questions. What percent of the bell is shaded? So I'm going to go back and forth. If you click here, let's double check the browser. Same thing. I have a formula card, and you go, oh, there's the formula card. That's the one I was saying I could use on my test, blah, blah, blah. And then you go down to this picture here of what's called the standard normal distribution. Right? You go to that picture, and I'm kind of curious. Let's see what happens if I do the same thing on the iPad. Let's click on that. Right? Oh, so what does it do? Open this? Yeah, let's open it. Same thing. Good. Okay, nice. Look at that. Okay. And here we are. That picture should look that picture should look familiar. And I'm so glad I did this. Oh my God, look how wonderful this is. Oh, but I can't write on this. Darn it. So it's not that wonderful. But we can see. We can see. Okay, so we want to know what percent of the bell is shaded in this picture. Well, it's very difficult to answer. In fact, you can't answer it without really using that table here. So here's our first step. Here's what we're going to try to do here, ladies and gentlemen. I'm telling you, look at the table, the Z table here. It's good only for this area. This is what this is good for. This is why they gray this out. I'm going to make this in red. You need to know that Z value, though, ladies and gentlemen. Okay? We need that Z value. Oh, we're going to work with this table. Good. Okay. So here's our first question. What percent of the bell is shaded? This is a standard normal distribution. The center here, the mean is 0. And positive values are to the right of 0. Negative values are to the left of 0. So in this example, this is my Z, ladies and gentlemen. Z here is going to be 1.36. I have to find, using the table, okay, I got to use this table. What's that value for Z? What percent of the bell is shaded? It's very simple. Using this table, I just have to know the following here. Let me remark that I need to actually do two things. I need to find a row and a column. So I need a row and a column. Okay? The first two values here around my decimal point, around that decimal, right to the left, 1 digit, to the right, 1 digit. The row here is 1.3. So let me erase this. Have you guys focus on that. This is that Z value. So I'm going to look for a 1.3 row because I'm going to look to the 2 digits around that decimal, and then I'm going to look at this last digit, which is a 6. But that 6 is in the hundredths position. So the column I need to find is determined by this value. You're going to look for the point, put the 6 in the hundredths position. It must be in the hundredths position. find this. Oh, that looks kind of nice. So because my 6 is in the hundredths position, put a 0 right here and put the 6 here. This is what we're talking about. So notice this. Isn't it true that if I add 1.3 with 0.06, don't I end up with 1.36? And the answer is yes. So I'm on the right track. Okay? On the right track with that. All right, just kind of get things here straightened away. Okay, now you might say, but Mr. Judge, how do I do this? Here's what you guys do with this table here. I look for the 1.3 row. You say, where is that? That's right here. So here's a 1.3 row. Oops. Yeah. And then I have to look for the 0.06 column. So you say, where's that? That's right here. So the 1.3 row with the 0.06 column, because my Z value is 1.36. So if I use the highlighter, (1.3 row, 0.06 column. Okay, and I'm going to undo those things. I want you guys to find 1.3 row, 0.06 column. We're going to find the value in the intersection. 1.3 row, 0.06 column. Take a look. 1.3 row, 0.06 column. What number do you guys see in the intersection of 1.3 row, 0.06 column? You guys should see what? 0.4131. Good job, Joanna. That's what we're looking for. What that means here is we can replace this with 0.4131, which really means 41.31% of the ballot is shaded here. Okay, because this is the decimal representation. So we found from 0 to Z, Z being 1.36, about 41.31% of our ballot is shaded. This is what we're going to need to use here for answering some of these questions here, ladies and gentlemen. Okay, so I want to go through all the details for those of you guys that have calculators that you're going to need this detail. All right, good job. Okay, we're playing the game again. 1% of the ballot is shaded, but this time we got a user table. We're going to think a little bit here. All right. Okay, let's look at the next one here. Notice what they gave us here. The Z value now here, ladies and gentlemen, because this is a Z value. Let me write here. That's a Z value. And I'm going to use the other color. So I have to toggle. We need to write this Z value as a row plus a column. But the digits to the right and left, the single digits, is going to be my row. So this row is 2.5. And then you said, but Mr. Judge, in the last example, the digit here in the hundredths position was my column. And I'll say it still is. So if there's nothing there, put a 0, which means your column is 0.00. Remember that hundredths position? So isn't it true if I add 2.5 plus 0.00, don't I get the Z value of 2.5? The answer is yes. But I need a row of 2.5 now and the 00 column. That's going to give me what percent of the ballot is shaded right here. So let's go back to our table, but this time, let's erase. Our Z value is 2.5. So we need to find the 2.5 row. We got to erase this. So in my picture, 2.5 is right here. All right, there's my 2.5 row. And then I need the 0, 0 column. And you say, but Mr. Judge, where is that column going to be? Well, that's the first column here. There's a 0, 0 right there, ladies and gentlemen. Okay, it's the first column. It's 0, 0. We got the 2.5 row. So if I follow, and let's try that out. 2.5 row, 0, 0 column. What number is in that intersection? And it's going to be hard to see. I'm going to erase the row and column. And I'm going to show you guys what this is. I see if you guys can see that. What is that, ladies and gentlemen? 2.5 row, 0, 0 column. What is this? That's the decimal representation of what percent of the ballot is shaded. That's going to be 0.4938. 0.4938. Thank you, Joanna. All right, 0.4938. Oops. So here's our answer, 0.4938. But since they said what percent of the ballot, that's 49.38% of our ballot shaded there. This is by using the tables. So ladies and gentlemen, this is how this was traditionally done. You give this to students. They use these tables, and they're able to answer these questions. Okay, so let's proceed here. So using the table, what percent of the ballot is shaded? Look at the z-value now. They give us 0.68. So let's think about this again. My z-value here is 0.68. We need a row. We need a column. Right? Because the z-value here will be some row plus some column. So the digits to the right and left, the single digits of the decimal, we got to look for the 0.6 row. The next digit that's in the hundredths position is an 8. So I got to look for the 0.08, the 8 in the hundredths position, that particular column. So notice 0.6 plus 0.08 does give us a z-value of 0.68. So you're adding your row and your column, and this is a way to just create a table to find what percent of the ballot is shaded here. So that's what we want to know. We don't know what that is. So let's think. We need 0.6 row, 0.8 column. Go to the table. So we got to erase some things here. We need 0.6 row. You say, where's the 0.6 row? It's right here. 0.6 row. But we also need the 0.8 column. You say, where's the 0.8 column? Well, it's over here in the corner, 0.8. So you say, well, how do I find that? Well, take the 0.6 row with the 0.8 column. We got to see what's in that intersection. And let's double check. Is Joanna correct? Oops. Is it 0.2517? I think you're right, Joanna. It's 0.2517. All right. Sorry, 0.2517. So let's go take a look. 0.2517. And we found what percent of the ballot shaded? 25.17%. All right. And that's how we use a table. It's not too hard. People have been doing this before you. People are going to continue to do this after you. So it's 0.2517. That's what percent of the bell is here. All right. So you could say, is that 25.17%? It is. That's what that means. And this table is only good for 0 to some z value. And then you say, okay, what about the next one? Well, here z is 3.05. So let's try this out. A row plus a column, ladies and gentlemen, the 3.0 row, don't forget the 0.5 column, because that 5 there is in the 100th position. So 3.0 row, 0.05 column. This is going to give us what percent of the ballot shaded using the table. So, erase all this. We need the 3 row. And you go, where's that 3 row? You're going to look all the way at the bottom here. There's 3.0. It's like the last. It's the last row. Now we need the 0.5 column. You go, where's the 0.5 column? It's kind of like in the middle. 0.5 column. So you say, okay, I need the intersection. And you have to tell me what number is in the intersection. Could you guys see that? I can see it. It's going to be 0.4989, right? It's right in here. Guess it didn't like me doing that. 4989. Okay, hopefully you guys can see that. 4989. All right, 4989. 49.89%. Oops. 49.89. So all right, thank you, Joanna. And yeah, got stuck, froze. 4989. You froze. Okay, 4989. Let's go back. Okay, document open. No, I don't want to rename this. Okay, let's see if this works. La 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 la. Go back. Okay, Word. All right, 4989. All right. All right, come on. Let's see. What do you want to do? We don't want to rename you. We want to open you. You froze on us. You know what? Maybe I have to double. Oh. There we go. It's open. Open. All right, we're open. So that's 4989. Let's see. I think Joanna has it still up there. I wonder what page that was on. There's 58 pages here, so you guys know. 4989. There we go. All right, it's still there. 4989. 4989 3.05. Okay. Finally. (49.89% of the bell). That's shaded between 0 and 3.05. Okay. Now let's keep this interesting here. Let's see if you guys are really awake. They want to know what percent of the bell is shaded here. And this is what's going to get people. You see, in this example, I have a Z value of a negative 1.36. And people here are going to say, oh, Mr. Judge, I can't do this. It's a negative Z value, negative 1.36. No, I don't have a table that has negative Z values. All right, let's see if any of you guys have stood with me on this. Let's ask you a question here again. What did we say last time? We said, how do artists define beauty? Because we don't have a separate table of negative values. How do we answer the question when we have only a table of positive Z values? Goes back to that issue of beauty. Again, who is beautiful again? Right? We're all beautiful. What's the artist's definition of beauty? A face that is, what do we say? Anybody remember? A face that is what? How beautiful. Hopefully that weekend wasn't too long, right? How do we define beauty again? What do we know about these distributions? What are they? Anybody remember? Aren't they supposed to be, what's the word? Symmetric. You guys are going to use symmetry. You're going to put a mirror across the mean where there's a 0, and you're going to reflect this curve to the other side. And you go, what do you mean? Yeah. Positive 1.36. So here's what you guys do. Thank you, Cassandra. Thank you, Catherine. Okay, you guys got the right idea. Symmetrical. So what you got, thank you, Matt. So what you have here, if you know the area from 0 to 1.36, then you know this other area because of symmetry. Okay, that's what you're going to use, the power of symmetry. So we have to find 1.36. I don't know. Did we start the day with that? You guys remember we need a 1.3 row. And we need a 0.6 what column? Remember, 1.3 row, 0.6 column. Did we find that? Let's check. No, not there. Not there. Not there. Ah, that was the first one we did. Was it the first one? Yeah, it was the first one. So we already found this one. We found that that's 41.31%. But that's for positive Z values. That's for 0, right, to 1.36. But because of symmetry, I'll say it again. But because of symmetry, remember that answer, 4131. This here in the past was 41.31%. That means this is also 41.31%. So as you guys can guess, yes, you're going to use the idea of symmetry here. And that's really why you only have one table. You see, publishers, what they like to do is they like to reprint textbooks. Now, in some cases, it's necessary because some disciplines you have to. The discipline changes. Math, however, does not. So you don't need 2 tables, 3 tables. You don't need bombarded with a bunch of different tables. All you need is one. And I've been using this table for a very long time. So it's just going to be symmetry. If you know about beauty, then you know about symmetry. Then you could use only one table, even if they give you negative z values. See, this is negative. But that's okay. So just use symmetry, ladies and gentlemen, and all is well. And that's the idea. Okay? Oops, nope, sorry, it's not that funny. Just use symmetry and all is well. See? Told you guys would appreciate this today. Glad you guys are back. All right. What percent of the ballot is shaded now? Again, same game. And you go, oh, wait a minute. Like the last example, this is a negative. In other words, they want what percent of the ballot shaded here? I'm going to use symmetry. If I know the area here by my z table from 0 to 2.5, if I know what percent of the ballot shaded here, I find that answer, and it's going to be the same as the other side because of symmetry. All right, you guys okay with that? All right, so 2.5. I bet you we did that one because when I designed it, I usually design it that way. You know, don't have to do double the work. 2.5. Let's find that. There it is. 49.38%. All right, because of symmetry, 49.38%. So let's do this 49.38%. Oh, there we go. We go too far. 49.38% is from 0 to 2.5. That means we have here as well 49.38%. So don't let those publishers come in and try to sell you a brand new book with new tables, negative z tables. Remember, sometimes when people try to make things easier, they make it, it's not necessary. You know, just use symmetry. Think of beauty. Look in the mirror and see if you're beautiful. See if your face is symmetric, right? All of our faces, again, we've been through this, are not symmetric. Apologize for that. If you guys heard that. Anyway. All right. Our faces are what? Symmetric? Not really. Some people are more symmetric than others, and they're considered beautiful in terms of the world of art. I guess drawing. I don't know. Negative 0.68. You guys already know. What do we do? Use symmetry. So, I bet you I did this one already too. 0.68. I hope. Where is it? There we go. 25.17%. 25.17% is going to give you 25.17. Here we go. This is 25.17%. Because of symmetry, this is 25.17%. What percent of the ballot shaded? All right. Just use symmetry, ladies and gentlemen. And now I hope we kick this up. Oh, we already have this one. All right. You guys know the drill. Because of symmetry. 3.05. Hopefully we have that. 49.89%. We did that one already. So let's go down. What did we say? 49 point what? 89. 49.89. So 49.89%, and this will be 49.89%. Okay? Just use symmetry and all is well. So I'm going to check this really quick. Apologize. Send them in lecture recording. Anyway, okay. So symmetry. And now it just got so difficult, ladies and gentlemen. What percent of the ball is shaded here? Notice they're going to want us to put these things together like we did last week. What percent of this ball is actually shaded? So here's what you guys can do. If you know this right portion, which you do 1.36, and you know this left portion, which you do is negative 2.5. Remember, these are z values here. Okay, so you have two z values. So this is kind of thinking of this in some ways. If you look at the book, they want to know everything between negative 2.5 and positive 1.36. This is the notation the book uses because you're looking at an interval right down in here. Okay, this is between these two numbers. They want to know what percent of that ball is shaded. So I need the left portion plus the right portion. So you have to really, ideally, figure out both of them. So from 0 to 1.36, I think we have that somewhere. 0 to 1.36, I hope. Yeah. It was 41.31. Remember this one? 41.31. So 41.31 is over here. That's this portion here, ladies and gentlemen. And then we need between negative 2.5 and 0. We need this portion here. Okay, so you guys know, look for this problem we did. Okay, the 2.5. Okay, let's find out what that is. 2.5. I think that was the second one we did. Oh, no, it's right here. 49.38. 49.38%. So you're going to use that 49.38%. You're going to use both of these. And let's see if you guys remember last week. What did you guys do last week with these values? Do you guys remember what you guys did? Right? What did you guys do last week? Stop and think. Right? What do I do with these numbers, ladies and gentlemen? Since I want to know what percent of the ball is shaded, what shaded is in blue, it's composed of two sections, some on the left, some on the right. What do you guys do with these numbers? Anybody know? We have someone guess? What do you guys think? What do you do with those two? What's the word I'm looking for? You guys want to what? Let's see if I can put it in gold. We want to what with these? Thank you, Jessica. We want to add. We want to add these. Right? So thank you, Cassandra. Thank you, Jessica. So we want to add these, ladies and gentlemen. You say, okay, in order to add, we got to go to our TI then. All right, let's bring out that TI and say, okay, TI. Let's put some things here. It's weird. All right, TI, what do we do? we're going to take the what? 49.38 plus 41.31. And ladies and gentlemen, you end up with 90.69%. Thank you, Jessica. This is what we end up with. Okay. So if we go to the, well, we're not going to the, we're going to the iPad, right? So this is 90.69%. This is the total that we get when we add. So let me erase this. Let's put this, maybe 90.89% of the bow. 90.89%. I don't know if you guys can see that in gold. Right. Is it 8.9 or 6.9? Oh, 6.9. Let's put a 6. And, you know, that's in gold. It looks a little tacky. Sorry. %. That's the percent of the bow that's shaded between negative 2.5 and positive 1.36. So I want to let you guys know that your book gives you this kind of notation. I'm going to give you this idea too, that this is a probability, because remember, if they mention probability, the difference between percent and probability is really where you place the decimal. So this is actually going to be like 0.9069. It's the same answer. We'll get to this more detail tomorrow, but I just want to throw that out now. I also want to throw out to you, some of you guys are going to be happy, some of you guys are going to be mad. I don't know. You're going to say, Mr. Judge, you mean that there's a procedure in the TI? And the answer is yes. So I have in your instructions here, we could use the table and our regular calculators, the way I just showed you guys. Because I show people how to do it both ways, using the table and the TI calculators. So you might say, well, you know, I found a TI. Anybody here find a TI, an offer up or something? Maybe I'll go buy one too, you know, find one. I'm not going to encourage you guys to go out at all. Don't do that. Maybe order on Amazon. I don't know. Or somewhere else. But let's try this on the TI. See the instructions? The instructions say the following. Let's do this here so you guys know, right? Go in the TI. I want to go to the distributions. So distributions is second and this key here. My instructions say go all the way down to the normal CDF. So normal CDF is actually the second one. Wow. It's number 2, not normal PDF, normal CDF. Normal CDF, finding area between two Z values. This is what we're doing. So we find that distribution, hit enter. Now I need a lower value. I need a lower value. Okay, what's the lower value? Well, that's negative 2.5, right? So we put negative 2.5. The lower value is the smaller value. And that was 2.5 all the way up to, if we remember, 2.5 up to 1.36. So I go down to the upper value, 1.36. Okay, good. Now let's double check. If my mean is 0, the standard normal mean is 0, and the standard deviation here is 1, it is. I just have to put those values in, say I want to paste this in, and then I hit enter, and sure enough, what do you guys get? If you approximate this decimal place to the tenths, 100,000, 10,000s, right? Maybe we should go back to the iPad. You say, well, how do I do this, Mr. Judge? Well, point what? 0.906875 tenths, 100,000, 10,000s. Look at the digit to the right. This is 0.9069, which is 90.69 written as a percentage when you move the decimal 2 spaces to the right. So this is exactly what we got earlier when we added the areas using the what? The Z table. So I'm showing you guys how to do this, you know, by both methods, because some people, like Cassandra said, guess what? I did find one for 25 bucks. Oh my God, that's fantastic. You almost got $100 off. That's amazing, right? Good. Okay. Well, I guess you could do this, you know, or just use your table. So I want to show people how to do both. Okay. So it's good for you guys to know how to do both. But anyway, I'm just going to go through these things now. So as you guys can see, you know, it all makes sense. It's all consistent. There you go. All right. So if we go now to the next one, what percent of the ballot is shaded? I would say do two things. I need to know what percent of the ballot is shaded from 0 to a positive 2.5. And then I also need to know, maybe I'll change the color. I don't know. What percent of the ballot is shaded on this other side? All right. From negative 1.36 to 0. So let's actually do the 2.5 first. I think I've seen that somewhere. Oh, yeah. It's right here. 49.38. Prior problem. And in fact, this is a bit weird. I wonder who wrote this question. That was me. Negative 1.36 and 0. Oh, it's this one here. 41.31. Huh. All right, whatever. You guys know, what do we do to get the answer? Because we want to find what percent of the ballot is shaded for this whole thing. Maybe that looks better. We what again? We add. Oh, that's interesting. All right, let's add by the TI. And we say, okay, TI, I want 41.31. And you know, when you distribute, or I should say, when you add, it's commutative. So it means it doesn't matter the order which you add. That's what we just did. We get the same answer. All right. Let's see what the menu says. Let's find distribution. Go down to number 2. The lower value in this case is a negative 1.36. The upper value is a positive 2.1 or 2.5. The mean is 0. Standard deviation is 1 because it's a standard normal distribution, and you get the same answer. Okay? So, ladies and gentlemen, this is a good thing. So you're learning how to use both these things today, so you guys know. Okay. Negative 0.68 to positive 2.5. So you could say the 2.5 we already found. 49.38, prior problem. There it is, 49.38, and then the negative 0.68. So negative 0.68, where's that at? 0.68. 0.68, oops. Oh, there we go. See this? That's 25.17. So I guess you can say this portion, 25.17%. And again, we need what percent of the ballot shaded. This here, we add. All right, let's ask the TI. $25.17 plus 49.38. Get these values here, 74.55% of the bell. Let's see if this is accurate. Go down to NormalCDF. The lower value now is, use this negative key, 0.68 for the lower value, and then the upper value is 2.5. Oh, it's the same. It's already entered there. Mean is 0. Standard deviation is 1. It's the standard normal distribution. Sure enough, we get 0.7455 approximated to the 10,000th position. So, yes, ladies and gentlemen, it's the same answer, 0.7455. Anyway, let's get rid of 0.7455. Right, and that was 74.55%. So that's what percent of the bow is shaded in there. So this is a good thing. And I want to kind of get down to show people some more. Let's just try the TI for this one. Or maybe you should just let you guys try that one, right? Well, let's try it out ourselves. Let's do it via TI. How's that? Say second, distribution. Go down to number 2, NormalCDF. Lower value is a negative 3.05. The upper value is a positive 2.5. Hit mu is 0, sigma is 1 because it's the standard normal. It's a Z distribution. And we're going to get 0.9926%. So I would say to you guys, oops. 0.9, well, they ask what percent of the bow, right? What percent of the bow? This is 99.26% of the bow is shaded. Now, remember, your book is really saying, just so you guys know in terms of notation, probability of negative 3.05 less than or equal to Z, less than or equal to 2.5. That's the notation-wise. This will be probability values, but they asked what percent of the bow is shaded. There's a different kind of question. Percent is 99.26%. Anyway, just reminding you guys a little detail so the TI can come through. Now, what's going to happen is you're going to have a right tail. So the question becomes, you have to remember how to do a right tail. And I'm going to remind you guys doing a right tail. Doing a right tail starts with, always, it starts with 50%. So you're going to say, I have to take 50%, and then I have to throw out what is missing. Remember this right tail? We have to find, ladies and gentlemen, I know this is a right tail. This goes on forever. But we start with 50%, and we always throw out what's missing. The only problem is we don't know what's missing. This is what we have to find. Now, we have to find that using our table. You go, using a table? Yeah. So to find what's missing, I got to find from 0 to 3.05. In fact, that looks familiar. I've seen it. I already know 0 to 3.05. Go all the way back, way over here. We know that by using our table. It's right here. Right? This is 0 to 3.05. That portion's missing. 49.89% is missing. So 49.89%. So what I'll do now, ladies and gentlemen, 49.89%, I'm going to have to subtract this portion. $49.89%. I subtract what is missing. So I take 50 minus 49.89, and this isn't adding. What is that? This is subtracting, ladies and gentlemen. So go to the TI and say, okay, TI. 50% minus 49.89%. Hit enter. We get 0.11%. So this is in terms of percent language, ladies and gentlemen. So what percent of the bow here is shaded is 0.11%. That's what's in the right tail. That goes on forever. It's 0.11%. So this is how we deduce finding the percent of the bow that's shaded by the exercises that we work with last time and this time. 0.11%. That's not even 1%. So that's kind of why we did everything that we did, ladies and gentlemen. I set the table for you guys for 2 days. Hopefully you guys are understanding the process here. And then let's check to see what the instructions say in our, double check the instructions in the TI here. See this here? Here's what they're going to say in the TI. I want to remark, go back. In terms of notation, this is described as Z being greater than 3.05, meaning this is a lower bound value. And this goes up forever to the right, okay? This goes to the right forever. And you say, well, what does that mean, right? Well, going to the right forever means what?
To infinity and beyond.
So the lower bound value is this, and the upper bound value is again
to infinity and beyond.
Because this tail goes on again forever. It never ends.
To infinity and beyond.
Now that's going to be an issue because when we go to the TI, and here's what I'm saying to you guys, notice the lower, L for lower is 3.05. That's what we said. But the upper doesn't have infinity.
To infinity and beyond.
It doesn't have that. So enter a large number. So all that drama, just to tell you, ladies and gentlemen, the smallest value on the TI here is going to be, if we go to the distribution list, the second one again. Well, we know the lower value here is 3.05, and that's positive. So put 3.05. The upper value, there is no what?
To infinity and beyond.
Put a big number. Put 10. No, bigger. Put 100. Put 1,000. Doesn't matter. I'm going to put 100. Standard deviation is 0. Sorry, mean is 0. Standard deviation is 1. This is the standard normal Z table. Paste that in. And sure enough, you get the same what? Answer. However, this is in probability notation. 0.0011. So you say, is this going to be, oops, 0.0011. Here we go. Remember? 0.0011. Approximate to the tenths, 100,000, 10,000s. Well, that's probability language. This is what this is equal to here on the other side. 0.0011. But as a percent, ladies and gentlemen, we already have the answer. Let me just put that over here. Okay, so people kind of Z bigger than 3.05 is 0.0011 probability, and we got the percent already answer. Because they're saying what percent of the bow is shaded. So this is what happens when you have a right tail. I want you guys to compare and contrast what happens when you have a left tail. Because for a left tail, if you guys remember, it was still 50% minus what was missing for a left tail. So you had to find what was missing here. And you go, oh, okay, that negative 3.50, well, that's analogous to the other one. Since it was 3.5, we go, it's 49.89. Okay. So 49.89% is missing. So we already know what that one is, 49.89%. So we already did this. We get 0.00, I'm sorry. This is percent, right? So we get what? 0.11% as an answer. This is what's in that left tail. The real question becomes, what does this actually mean? Well, these are z-values that are to the left of that negative 3.05. So remember, here's that negative 3.05. You're talking about all these values to the left of it. Again, this is actually where?
To infinity and beyond.
So the lower limit is actually going to be negative what?
To infinity and beyond.
And this is my upper limit, going smaller to larger. Now that's a big deal. You say, why is that a big deal? Because if you go to the TI now, notice what I put here in your instructions. This is my lower, and this is my upper. Negative 100 is a finite number, but I have to use a negative. It's really a small number, right? Negative 1,000, negative 1,000,000, negative 1,000,000,000, negative 1,000,000,000,000. Oh my God, that's getting smaller. Further to the left you go, the smaller the number is. So the reason I'm bringing this whole issue up with the left tail is because when you enter your calculator now, if I go to the TI again, and I want to use this, and I say second distribution, go to the normal distribution, and now that's a negative, we're not going to say negative what?
To infinity and beyond.
We're not going to say negative infinity.
To infinity and beyond.
I'm going to use like negative 100 as the lower bound value. The upper bound is still negative 3.05. So you're going to enter that. Standard normal, mean is 0, standard deviation is 1. But this is what you enter in the calculator, going left to right. And notice you get the same answer, but it's in terms of probability. So if we approximate to the nearest tens, 100,000, 10,000s, okay, approximate to the 10,000s, what you get, ladies and gentlemen, is 0.0011. That's a probability value, and this is percent language because you're asking, again, what percent of the bell is shaded. So I want to show you this here. All right, what happened here? There's TI. And let's find the iPad. All righty, let's go back to TI here. I think I know what happened. Okay. So what I'm going to do here now is I'm going to get the iPad back, because evidently I can time out on my own machine. All right. Then I got to put a code here. 6795. Okay. All right, we're back. Okay, so I had to put a special code. So if I go back to the iPad, we're back. Good. Now, here's what I want you guys to think about. Let's try this again. We got a right tail. What percent of the bell is shaded? Right? Here's my Z value. We're trying to describe Z greater than or equal to 1.36. Okay? You say, why Z greater than or equal? Well, it's 1.36 and everything to the right, so that's larger, right? And that goes again to what?
To infinity and beyond.
So this is my lower value. And again, what?
To infinity and beyond.
Is the upper value. This is describing this interval here. Okay. Values that are greater than or equal to 1.36 forever. So in your TI, notice how I had to do this. Lower, upper. We don't have infinity.
To infinity and beyond.
But we do use a large number, largish. 100's not large, but compared to some of these other values, it is. If you want, use 1,000. Let's try this out. Let's go to the TI. And let's just say, okay, TI, second distribution. Go down to. Now, we say we're going to use 1 point what? 36. And you're going to go to a large number. Let's use 1,000 now. We get 0.8969 to the nearest 10 thousandths. So I'm going to write that here. And that's as a probability. Oops, sorry. Let me double check here. Let's not forget there's a 0 there, right? So 0.0869. That's as a probability value. So if you move the decimal 2 spaces over, that's 8.69%. That's in the right tail. All right, you guys okay with that? This is how we use the TI to deduce these answers here. Okay, 8.69% is in that tail. So it's up to you guys. We can go about it this way. I even have instructions for a left tail. And for the left tail again, this is the probability that Z is less than or equal to a negative 0.36. So let's double check. You say, why is that? Well, because we're going to look at all the values to the left of this number. Those are the values that are smaller than a negative 1.36. Smaller values live to the left. So this is where the algebra-ish prereqs come in, ladies and gentlemen. Algebra-ish, describing this as an interval. All the values to the left of negative 1.36, we write a Z less than or equal to that value. Now again, on the left, what do we think about?
To infinity and beyond.
So that the lower value and the upper value have to be identified when I use lower value, upper value, that's TI. Because going to the left forever for this left tail
To infinity and beyond
is what we do. So go to the TI now and you say, okay, TI, second distribution, go down to NormalCDF. Lower, I'm going to use negative 1,000 or 100, negative 100, negative 1,000,000. Doesn't matter. And then the upper bound is going to be, I believe that's negative, right? 1.36. Double check. Mean is 0, standard deviation 1. It's a standard normal distribution. And notice what you get. We get the same answer. But some of you guys may have noticed this. Let's write this down. This is the same answer as before because of one key reason, 869. This again is 8.69%. That's percent of the bow that's shaded. Because if you notice something here, this is a right tail. We have a positive 1.36. Left tail, we have a negative. Oh, it's because, again, we're simply also using symmetry, just to remind you guys. And that's why you have the same answer for these. So I just want to show you how you can integrate this technique into your TI world if you invest in it. If not, just do what we did last time. What percent of the bell is shaded? And so I have another right tail for you guys to do. I have another left tail. And let's try something like this to show you guys. Because I don't have a right tail anymore. I have a lower bound value. And I have an upper bound. This is not a tail situation. This doesn't involve that infinity stuff. This is looking at this notation-wise as my z value being between 2.5 and 4.03. Okay, this is looking at the between situation because z is between these two numbers. Okay, this is what we're talking about. This is that interval. This is the between. So you might say, how do I do this? Well, there's a couple of ways. If you remember, we'll start with a TI. It doesn't matter. Second, distribution, all the way down here. Oh, the lower bound value now is 2.5. And the upper bound value is 4.03. We get, as a probability, 0.0062. This is a probability value. As a percent, that's going to be 0.62%. So, 0.62%. So what we find here is just using the TI. The built-in, distribution menu, trying to find this. So we can do it that way. That's one way we could do this. However, if you said, Mr. Judge, okay, you gave me the instructions down here. I could use TI. Okay. What if I don't have that TI? And I'll say, okay, we can still do this question. Just think of what we did last time. What percent of the bell is shaded? So what we did last time was to remind you guys. I need to find the area or percent of the bell that would be shaded, the area that represents this portion to this portion. From 0 now, here's what we're looking for, to 4.03. So you say, I want to start with all this area. 0 to 4.03. Now, you may have that. You may not have that. I'm going to look at the table. And maybe we should go back to the table. Oops, let's go all the way back to the table now. And the table's all the way in the beginning there. Oh, my God. 4.03. So if you remember, I have to look for row 4, 03 column. 4.03. Let's go over here. Right? 4.03, I need the 4 row, and I need a 03 column. And I'm going to have you guys really take a look at this. Because here's what you want to see. It says 3.10 and higher. I don't even have a 4.0 row. Because 4.0 is higher than 3.10. So what does it say we do if it's higher than 3.10? Anything higher than 3.10, I mean that number and higher. So it's at least we use this value. That's what this means. We use 49.99%. 49.99 or 0.499 as a probability. All right. So you say, okay, I use that value. Let's go down to where we need to be. 4999. Let's make that smaller. There we are. Now you said that's from 0 to 4.03. We have a portion, Mr. Judge, that again is what? Missing. I just erased what's missing. I erased this portion. That's from 0 to 2.5. So I need to know how much is missing. 0 to 2.5. And you go, okay, 0 to 2.5. I think that sounds familiar. It's somewhere here. 2.5. I hope we find it. Should be in our notes. Oh, it's 0 to 2.5. It's coming up. It was 49.38. 49.38% is missing. %, is gone. It's missing. So since it's missing, ladies and gentlemen, you say, what do I do with the two numbers? Right? What do I do with this? I'll write it up here. 49.99 and 49.38%. What do we do? Do we add? What do we do? Remember, you subtract here. 49.99 minus 49.38 because it is missing. It's gone. So if I say, okay, TI, 49.99 minus 49.38%, we get is 0.61. Now you say 0.61. That's right. That's a percent. So this should be 0.61%. Now you look at the calculator, you go, but Mr. Judge, the TI gave me 0.0062. And I'll say, yes, it did, because these are approximate answers. Okay, but the TI gives you a probability value. So if I did this, I get 0.0062, and that gives me 0.00, I should say 0.62%. These are approximate, okay? Because 4.03 is really far from 3.10, and anyway, they're approximate. So this is how we use the TI calculators, ladies and gentlemen. This is what we do here with this. And so you can use either the TI, or you can actually use the calculators that you guys have, right? And you could deduce this using the table. So what we did last time is what we're doing today. I'm going to say to you guys, look over the rest of these and try this out on your own, with your own calculators, ladies and gentlemen, and see how that goes. And, we're going to see how to use this tomorrow into how to do a real question. All right, we're going to look at how do we really do a question here for these. Anyway, I hope you guys enjoyed the lecture today, enjoyed how to do the TI. I hope you guys are healthy. I hope you're well rested. Make sure you study these things. In your book, I believe I gave you homework last time. And if I didn't, if you guys remember, you do 6.1 in your homework. If you guys like, you could do, let's do this 6.1. You do 9 to like 39 odd on your homework. Let's write that down. And of course, on the web, if you go to the browser, we already gave you guys that last time. I said go straight to, the new library, and that was statistics lecture all the way down in your browser. What is that? Normal probability statistics lecture 12 on the web. And of course, you do the odds here because you have the evens, I guess. So here's your homework. And again, if you have any issues or questions, see me during office hours. I got to get set up for that. So I hope you guys are safe. Work hard. Prepare for the test next week. All right, you guys, take care. and have a good day.